All right, welcome. I'm very excited to be here. I'm very excited that you are here. Welcome to DroidCon New York. My name is Sam Edwards. I now work at Square. When I proposed this talk, I was jobless, but now I have found my home, and I'm very happy I'm here. So yeah, I'm going to be talking today about interception. So let's get started. In software development, we always have calls, right? We invoke something on A, and then we try to get it to do, we want it to complete eventually, right? So even if we just get a value, we're calling a getter. We call any other method, it's doing something. And as we make calls in software, there's a lot of things that can happen underneath the hood. We could just have normal logic, like if statements and things like that, or we could go through different layers of our system. So it's really an infinite amount of things that we can go through, but at the end of the day, object A that you're calling on only needs to know that it's going to get something like the result of B. It can go through however many things it would like to. This is my keynote magic move skills that I have, so let's see what we have. So this is a call chain, and this is a call chain with interceptors. So an interceptor, okay, I guess we'll go into what the definition. All right, here we go. So this is a kind of analogy that works really well for this. So if you've heard of the telephone game, it's a game that mostly you play as a kid, but we could play as an adult if we wanted to. But the person in the green on the left whispers something to the next person, and so the person in the green is the person you're making the call on, and at the very end you want to get to B. So if this was an interface, there would be an interface of person, and then there would be a method called like say something, right? And then you have a message on there. So the green person tells it on, and each one of these steps may be hear everything correctly. So it would be like, hey, do you want to get some coffee at DroidCon? And so you tell it down the line, and the yellow person at the end hears, do you want to get coffee at DroidCon? But along the way, you might get to a point where somebody didn't quite understand and said, do you want to get toffee at DroidCon? Right? So each one of these steps has the ability to either pass something through, change something, or you could have somebody just like, if the blue person there just said, you know what, I'm going to just skip out a line and go tell the yellow person myself, right? They could just kind of do that. So there's a lot of things that can happen, but because we're following this interface of a person saying a message and it goes through, you can kind of transparently stack up however many people you want, right? The telephone game could be 100 people, could be 2 people, but they're all following that same interface, so we can chain these together. Welcome to the interceptor pattern. So that's why I named this talk Interception, was based on this, but today we're not just going to talk about the interceptor pattern, we're going to talk about other patterns and tools that can achieve the same sort of thing, but first let's dive into this. So the interceptor pattern is a way to change or augment the usual processing cycle, right? So as we saw with telling somebody something, you can go ahead and each one of those could do something normal, or they could actually change something or change the behavior. Additionally, the rest of the system doesn't need to know that something is going on. It's just going to expect that it's going to keep working as it was before. So object A is going to get to B no matter what, no matter how many things are in between. The system doesn't need to know that there's things in the middle. So this is a call chain with interceptors, right? So we've already talked about it a little bit, but each one of these is a interceptor. So each one is able to modify something or print something, and we'll go through some examples of the different types of interceptors that are out there. So categories of interceptors. We have a pass-through, which means that you just go ahead and tell the person next to you, let's get coffee at DroidCon. You have logging, which might mean that the person writes down what you said, let's get coffee at DroidCon, but they tell the next person something. You have a modifying or transform one, where somebody did, instead of saying coffee, they say toffee, and that happens, but it goes down the line. And finally, you have that person in blue in the middle that just was a circuit breaker, and they're like, you know what, I'm going to tell you whatever I want to. So I first learned about interceptors back in 2014 or 2015. I was working on a project, and we needed to know what the networking traffic was on the app. And so I was kind of new to this. I'd used some networking libraries, but I found, using OKHTTP, there was this tool called Stetho that was available at the time. It was something that you added a interceptor to your code, and basically it tunneled all that traffic over ADB to your computer, and you could just see everything in the Chrome developer tools. I think this is now called Facebook's Flipper library. but it's when Facebook did more open source. So I don't want to get too much in the details here, but there are two types of interceptors in OKHTTP. There's ones that happen at the application level, and the other ones that happen as things are going over the network. But the thing is here, these are a chain, right? So as you're making a call, like let's say you have a GET request to somewhere with some headers and things, it's going to go through a chain of interceptors, which could be none or it could be 20, and then that'll go out to the server, and then as it comes back, it'll go through the interceptors again, coming back in the response. So it's really powerful because we can add on as few or as many as we want to do all those sorts of behaviors that we've talked about. So let's look at some examples. Cool. So adding an interceptor to OKHTTP is beautiful. I really love this library. I guess I'm biased because I work at Square, but I wasn't biased, 9 years ago or something when I first started using this. So yeah, you just have a lovely builder pattern, especially when we lived in the Java world, builder patterns were the best. All you can do is you say, hey, add an interceptor. And if you want, you can say, add another interceptor and another, right? So that same concept, but as you make your calls, it's going to go through each one of these. And and the reason why that works is interceptor itself is an interface. It has a request coming in, and it expects a response coming out. So let's look at these examples of the different types of interceptors that we can see in OKHTTP. So this is a pass-through example. So this is the thing where somebody just says the exact same thing over. So you get this interceptor chain, which is that chain of things happening, right? So the chain itself is able to say, what is the request that I have? What it needs to do to fulfill its contract is say proceed. So it'll say, go ahead and proceed with this request, and then the chain will come back and give you a response, and it returns it. So this is implementing an interface that's just called intercept, the one method, but you have this really nice lambda. So you can just do anything you want here. And this is one that just says, go ahead and proceed with the request and return a response. Next, we have a logging interceptor. So I think it'll catch up here in a second. So logging interceptor is similar. You still have the same lines. You get your chain, you do your request, you return your response. So this is where it kind of ended before, but we've added these lines here. So we have a print line. These were the request headers, and these are the response headers. So I like doing live stuff, so I'm going to be doing that a lot today. So here we go. So this is, let's see if I can zoom in a little bit more. Cool. This is our OKHTTP client that we have. I already have some pre-built things, so let's go ahead and add an interceptor like we wanted to do. No-op interceptor, or I guess it's called pass-through interceptor. Before I do that, though, let's just run this code and see what it looked like in the first place, because that's important. I have a JSON endpoint from a demo app I have. It's on S3. It's just a JSON file. So in this example, I go ahead and call it, and I get back a list of video games for Nintendo, Super Mario Brothers, and stuff like that. So if I go ahead and add this no-op pass-through interceptor, and then I run the same code again, it does exactly the same thing. And just to show you that it is the same thing we showed in the slides, a pass-through interceptor literally is the request and the response, and nothing else changed. I wanted to show you the logging case now. So if I add another one, add interceptor, log headers interceptor. So I add that, and I run it again. Now what you'll see here is that it has the headers, right? So as this went through, here's the request headers, the response headers, and then here's the body at the end. So one thing that you might notice is there's no request headers, right? And the reason is this is one of those application level interceptors that we had, not one of the network level interceptors. So in order to see that networking traffic in its pure form of what's going over the wire, we say add network interceptor. And when we go ahead and run that in OKHTTP, they put that further when the network is actually going across. So you're able to see this is coming from the user agent OKHTTP, and it's gzipped and things like that. So that's really important to have those two different places. However, these both implement the same interceptor interface, which is nice to be able to put it in both. All right, let's keep going back to Keynote. So the next type is a modifying interceptor. And up here I have a ninja because they're secret, they're stealthy, and they might modify something, right? But this could be bad or it could be for good. Just like, Ninja Turtles are good, right? It's all right. And we're in New York, that's great. Cool, interceptor here. So in this case, we're gonna modify the request going out. That's this example. So we get the chain, and then what we're gonna do, instead of just sending the request to the chain, we're gonna actually create a new request that does something special. So you can take that request and then create this new builder that lets you take the existing object but add stuff on top of it. So I've added the extra header, and then I'm going to say proceed. So let's go ahead and add that on ourselves. So we'll go ahead here and we'll say add interceptor, and we'll add the, header interceptor? Add header interceptor, and we will run. And then we will see at the top here, request headers, DroidCon New York City, right? So it works. It's great. And yeah, the implementation, again, I'm not lying in the slides, is exactly the same thing. All right, next we have a short circuit interceptor. My little lightning bolt, don't get electrocuted. But in this case, we're that mischievous person in blue in the middle. I'm sorry I'm calling them out, but stock photos, why not? In this case, I am getting my request, but I'm not gonna actually send it on. I'm not gonna say chain.proceed. I'm not gonna pass it along the line. Instead, I'm gonna just generate a response myself and say, oh yeah, the request was actually this request, but I'm gonna just make up the response myself. So the body of this will just say short-circuited, and that's what we're printing out. So come over here and we'll say add interceptor, and we'll say short-circuit interceptor, and we will run. And there we go, short-circuited. Because we just basically along the line, we said, you know what, I'm just gonna go ahead and return. All right, and then we have a caching interceptor. So this is a type of short-circuit interceptor in some cases, right? So a cache in general is something that can save a value of something that got computed before and then return that back to you. So in this case, we have a really super simple cache of here's the URL I was trying to hit, here's the response body as a string. So in this case, the request will go through, and then basically I'm just checking my cache, which is a hash map, saying, does this exist? If not, go ahead and execute my request and add it to the cache. And finally, I'll go ahead and use it. So if we did that, I could go ahead and say, actually that short circuit interceptor is gonna mess us up. So we'll say add interceptor, and we'll say caching interceptor. So we'll run that. And as you'll see, nothing is different because we only called it once. And caching is valuable when you call it more than once. So let's call it multiple times. Now we'll run. And inside of here, you'll see that the headers are printed out once. And other than that, we're just getting back the responses because the cache has actually said, you know what, I'm going to short circuit and return what I have. So we didn't actually have these things go over the network. All right. OK, HTTP interceptors are beautiful. Just like this purple shirt. My daughter loves purple. I bought the purple shirt. It's beautiful. They are beautiful because they are composable. Composability, you'll hear things, composition over inheritance, but composable means you can just add different things together and it works. You don't have this thing where you're extending something, extending the behavior. You just kind of add things together. It's flexible because of that, and it's very powerful. So I love this pattern. This is how I got introduced to interceptors in general. And let's continue on and see other ways that we see this in our software development. But first, pop quiz, as my CS instructor used to say. All right, what type of interceptor is this? Bingo, short circuit. So in this case, if you're not familiar with American football, there's a quarterback. Its goal is to throw it to its player down the field. But in that case, the defender went ahead and grabbed it and intercepted it. So that is an interception, but it's, an overloaded word in this case. So what that looks like, if you want to look at it, I really wanted to use magic move here, so I apologize. So anyway, they throw the ball to B, but hey, that mischievous blue short circuiter came in and took the ball. So now you know American football a little bit if you didn't know before. So recap. So interceptor pattern benefits. We've gone over a lot of these examples, right? So the benefits are this beautiful, clean abstraction so that you can kind of insert anything in that you would like to along a call chain. It's very flexible because of that. One thing, 20 things, doesn't matter. Super testable, because I can take these interceptors and just test them on my own, ensure they're doing the right thing. I can test a chain of them together. They're very adaptable. I think I spelled that word right. I think adaptability. And they're composable. So what's nice about, I think I have one more thing. Yeah, and injectable. So if you close your eyes and don't close your eyes. If you replace the title slide, the title up there with just interfaces, it's exactly the same thing, right? Because interceptor pattern is enabled by interfaces. That's all we're talking about here. Because you have an interface, you can go down the line and you can intercept things and do different things, right? So as long as that first call is implementing an interface and you're calling something on there, it doesn't matter how you get to the end. So you can add as many interceptors as you would like. Let's go to Kotlin flows. There we go. Oops, I have to go through all these again. So Kotlin flows. Everybody knows flows now. I think it's been enough years. It's from the Kotlin coroutine library. But the standard, you can create a flow. A flow is basically just a stream of objects coming through. So in this case, I'm going to stream object 1, 2, and 3, and then that flow you can collect, which means like start pulling these flows down. So I think I'm going to do this all as a live example. I was thinking about that right before here, so let's do that. So flows. Here's our Kotlin flows thing. So this is just what we were going to see in the slides, except you might get a little preview there. We'll put it down here, so maybe it's more of a reveal. So we have our first collect thing here. We go ahead and run it, and what we see is nothing. Because we've collected the flow, this does mean that like we're actually executing and like pulling everything out of the flow, but we haven't done any operators on it. We haven't intercepted anything, so nothing's really happening. So let's do an on each. Pull that up. So on each means that on each item of the flow that comes through, I want to do this thing. And so a flow has a generic type that comes through, and because these all implement an interface with coroutines, you're able to chain these things along, just like we could in the interceptor pattern. So if I go ahead and play this, what we'll see here is logged 1, 2, 3, because every single time the flow emits, we're doing on each and then collecting and going through. Let's add the next line. Hidden down here so you don't know what it is. All right. So we can go ahead and add 100. If we do that, we'll still see the same thing because we didn't log it, right? But all right, pop quiz. What kind of interceptor is map in this case? Modifying, exactly. So it's going to, a map, what it does is really nice. You get the value coming in, and you have the opportunity to change that to anything else you want. So it's an item you can change. In this case, I'm taking that 1, 2, or 3 as they come through, and I'm going to add 100. So when it goes to the next step, it is now changed. It has been modified. So the next line will get that. So let's just show that works by putting in another logging interceptor. So we'll run that. And in this case, you can see as things went through, we got logged 1, then collected 101. I don't know why I called logged and collected. But yeah, 1, 101, 2, 102, 3, 103, because it goes through like this. So yeah, live examples are better. Plus, so now we get to skip slides. All right. Da-da-da. You all know this. It's all great. Okay. Did I say something about beauty in software? Kotlin flows are beautiful. They are beautiful because they are composable, flexible, powerful. Do you see why I think that my characteristics, if I'm going out and I'm swiping left or right, they have to hit these 3 things. So, all right. So I was doing this presentation and I was like, Kotlin flows, cool, we're iterating through things. Let's try this out with collections. I mean, that for each and that map are also on Kotlin collections, so let's try it out. So let's just use the example again, it's so cool. Collections. So we've got this list here, and we'll just do the uncomment because it's not that much of a grand reveal. But we have a list of 1, 2, 3, and at the end, it'll iterate through all of it. So if I run it now, again, it's just going to do nothing. So we'll add the logger on each, and we'll get 1, 2, 3. So this looks very similar, right? If you looked at what we did before, we had a list of 1, 2, 3, we iterated through, we logged it, we got 1, 2, 3. Now I'm going to do this modifier on this, and I'm going to go ahead and run it. And again, we didn't do a printout, so let's do that here. But we did a modify here. And now we will print this out. But will this print out the same? You're smart. I did not know that. I was like, oh, this is a good example. This will do the same. But you were right. Plus 10 points. So let's go ahead and run this. And in this case, we'll get logged 1, 2, 3, collected 1, 2, 3. And I was like, wait a second, why is this the case? And I'm just calling this out because I'm not smarter than anybody else here. I thought this would work. But what's happening here is this list of 1 through 3, each one of these things is going over the entire collection and then passing it down and going over the entire collection. So the result of this map isn't a single integer value. it is now the full list of items plus 100. So just calling it out here that even though these operators are here, it doesn't mean it's the same sort of thing. And the reason why this is working though is because collection itself is a interface, we're able to chain these calls together. But we are operating not on a single element, on a full list of elements. All right, get to skip real slides. Cool, that should be it. All right, interfaces enable injection. Dependency injection is one of my favorite talks. I did a talk a long time ago about do-it-yourself dependency injection. It's fun, but not at scale. Have I talked about my love of interfaces? Okay, interfaces, here's a very simple example. You have a logger, a log, very similar to how we're trying to say send a message to the next person. So here's the message I want to log out. So because you have interfaces, you can have various implementations. Like, again, it doesn't matter. At the end of the day, it just has to adhere to that interface contract. So here's a system out logger. If you go ahead and call that, it'll just print to system out. And that same interface, if you wanted to inject it while you're running on Android instead of in a JUnit test, you could call log.d. And so, yeah, very similar. Both are allowing you to send a log message. But the thing that enables this is interfaces, right? Your dependency injection is enabled by interfaces. Right. And also, interfaces enable interception. So we've talked about this as well. Without interfaces, you don't have the ability to transparently go through this chain, right? If you have them, you can go through, you bypass any sort of like checks. Well, that's not true, but yeah, it works. So yeah, interfaces enable interception. Same cool magic move I wanted to show. But we can add, as long as we have a logger and we have an implementation, we can have as many different things that it goes through, and we can keep delegating down the line. So we pass on to the next one, pass on to the next one. Interfaces also enable fakes. So we talked about dependency injection and how an interface, you just have to satisfy it. A fake is a nice way to do this. It's basically providing a fake implementation of an interface, usually used in like testing or maybe in like an app where you don't want to like pull in a full dependency graph. In this case, it's kind of like the mischievous little blue person in the middle, because in this case you may have an interface on top of like a third-party library, and normally you pull that in if you run in production. But if you want to run the test or something, you can run the fake. Now this isn't really true that I'm gonna like cut in front of somebody. I'm instead replacing it, but it's the idea that like I can still swap out what I want. It's just not a interception chain. All right, Kotlin delegates. So this is a feature of Kotlin that is beautiful. And let's go into it. So I didn't use delegates here, but this is the original OG delegate pattern. This is how you'd have to implement it in Java. So this is one of those pass-through delegate loggers. So this means that I'm going to just tell the next person exactly what you said. So I implement logger, but I take in a logger. And so the only thing this does is it comes in, it says, hey, I want to log. And so I then delegate. I say, hey, actually, here, delegate, go do it for me. And so in this case, there's not much value. It's a pass-through. But this is an interceptor now, right? So you're able to intercept as it goes. You could do something before you pass it to the delegate, right? So this is interception, even though you're using a delegate pattern. And the way it's enabled is through interfaces. You're passing it down a chain. Let's see. Oh, yeah, live examples. OK, so delegates. Main delegate example. Alrighty. So we just had our system out logger. We know how that works if we run it. 1, 2, 3. I have the bonus one here now. I added, other than the examples, an error that prints to system.error. All right, so we have our pass-through. And when we look at it over here, we can add it on. Pass-through interceptor. Nope. Pass-through, what am I doing now? Delegate. Yeah. Pass-through delegate logger. So if I run that, again, it should just do the normal thing. And if we look at the code here, we have exactly like we had. So this is how you would have to do it in Java. But there is a special keyword inside of Kotlin called by. And so if I use that, I could do this, by delegate, and it looks the same. But what it's saying is, when I come in, anything that is implemented, that implements logger, I will send to the delegate. So all the stuff that I wrote here, I can now delete. And this is it. So what this means is, yeah, anything that you call on logger is now satisfied by the delegate. I'm just going to pass it on. So if I go ahead and run this code, it just does the same thing. So this is beautiful. Delegate is, yeah, use that please, the by keyword. Now we'll go into some more examples here. So your logging delegate logger. I'm sorry about these names, guys. But the goal of this is I have a logger and I want to do some delegation, but I want to log out what's happening at the same time. So this is very meta. I'm sorry. But yeah, main delegate logger. Let's go ahead and, oh, there's my logging. So we'll run that instead. And in this case, we have hello1. Logged hello1, so that's the kind of the change that's happening in there. Inside that delegate, it's printing out itself before it passes through, and then doing the real world thing. Now, if you notice here, though, it only says logged hello1 and 2, but there's nothing about 3. Why is that? So if we go into the implementation of this, we can see that we have used the by keyword, beautiful, but we have only overridden one function, log. So we've changed the behavior of one part of this by just log out onto print line. This is what's going through. Again, bad example. But I'm delegating that through and logging at the same time, but I didn't do anything to the other error message or the error function. And I don't have to because I have delegate there. I can just choose to override the things I want to. So really powerful again. Modifying. So a modifying delegate. In this case, we're going to go ahead and actually pass on to the delegate, but instead of just passing the message, I'm going to prefix what the date is. So this is the main delegate example, and we'll be using the modifying date prefix delegating log. Oh my gosh, must have been late. Okay, so again, we've gone ahead and we've done something special here. We've added that date on any logging message, but we didn't do anything to error. Next. A short circuit example. So in this case, I have a short circuit example that does the exact same thing for log, but on error, I actually don't do anything. I don't pass to the delegate. Because by default it would with this by keyword, but I'm going to override it and I'm not actually going to do anything. So let's use that down here, the short circuit. And if we run it, we will see the hello1, hello2, but hello3 didn't do anything, right? So these patterns of interception can be used in all these different ways, right? But it's all thinking about how do I design my system to do this? Interfaces. Yeah, let's keep going back. So interception recap on all these sorts of things. Our categories. Pass through, meaning you don't do anything. Hey, DroidCon for coffee. The logging, where you just write something down. Modifying or transforming, so that's when you say toffee instead of coffee, or you change something. And finally, that short circuit, mischievous person in blue. So why should you use interception? It's just beautiful, clean abstraction. It's flexible, testable, adaptable, composable, injectable. Again, take out Y and just say interfaces. I should have just, well, I guess I called this talk interception, interfaces, close enough. These are the things I want you to take away from today. And yes. So I would like you to use interfaces. I would like you to go out and if you use OKHTTP, and you may not know you use it because it's under the hood of retrofit, but it's there. Go check it out, the interception thing. Like try the logging interceptor that comes from OKHTTP. You don't have to write your own. There's one available as an artifact. Really powerful. You see everything in the console. Understand about Kotlin flows and how you can change things along the line, or log things and use those operators, and how you can use this by keyword to do the Kotlin delegate. So all these ways are different ways to do interception. Oh, and just design your code to be like this. So then I said in my syllabus, or whatever it's called, the abstract, I would do something on Java reflection dynamic proxies. And I told somebody about this, and they're like, that doesn't fit in this talk. But it's bonus, and it does the same thing, and it's really cool. So here's your bonus. And if you don't like Java, well, you have to use it anyway because you're on an Android, so haha. All right, let's go down here. So this is going to be kind of like, whoa, so just prepare for some reflection. All right, close all tabs. Let's go into dynamic proxies and the main one. All righty. So if you don't know what Java reflection is, it's basically like when you compile your code, Kotlin or Java, it ends up creating class files. And those class files are the compiled code resulting from that. And so all those things, when they run on the Java virtual machine, those are loaded into a class loader that kind of reads those class files, makes everything available on the class path. You've probably heard about that. And then you can instantiate these objects. So in this case, again, it's the same sort of 1, 2, 3. So nothing has changed. This hash code into string, these are bonuses that you'll see why. Let's go ahead and add an invocation handler. What's that? We'll find out. So if we go ahead and run here, you get all this goodness. So method log, that's the method I called. Here is the parameter I sent. Here is the actual result of the object, the method happening, the delegate of it. And then the result of that, it was a void, so it's, or a unit, so it's nothing. And I called log again, and I called error, and I called hash code, and I called the string. So these aren't even things in my interface, but I, with Java Reflection, have added this invocation handler that says basically, as long as you give me an object that's an interface, I can add one of these on, and I will see everything coming through this object. Let's look at the example here of, let's dive one step deeper. So how do we add an invocation handler? So this is all part of the Java util, Java lang reflect packages. But you can create a proxy instance. What you need is the class loader. So you can just say class loader, get system class loader. But honestly, any class that you have, you can just go ahead and grab it from. So if you just said like this class.java.class loader, it suffices. You don't need anything special, but it's just like this is the class loader that I need. We'll put it back though because I tested with this one. All right. And so now you provide a list of interfaces that you are going to add this invocation handler on. If you add something here that is not an interface class, it will throw up and it's really bad errors. But in this case, I'm going to install it on type logger. So I said, hey, you're adding an invocation handler on type logger, and here is the invocation handler. We'll go into that next. And at the end of it, I want you to return my proxy object as a logger. So let's look at this special invocation handler. Because if we looked up above where we called this, we said add an invocation handler being the log method calls invocation handler. So we saw how that worked down below already and the result of it. So let's go into that invocation handler that we added. Big screen. All right. So we pass in our logger that we want to make calls on. And the invocation handler, it only has to implement one method, which is invoke. And so what you get is the proxy object itself, which is the proxy object that was created when you created the instance. You get the method that was called. So this is the Java lang reflect method. And then you get all the arguments that were passed in. So in this case, I printed the method name. I went ahead and I printed out, if there were any arguments, I printed all of them out. And then I went ahead and I had to invoke these things in this special way. This was so weird, this little star thing. Kotlin and Java sometimes are not friends, because this is, but anyway, it works. So use this example. This is on GitHub, and I've already shared the link on Twitter, which of course, I don't know if we use it anymore, but it's there. Yeah, so that's that. Let's go to one step deeper of Java dynamic proxies. So let's do this down here. This big example, I'll paste it in. So in this case, whoa, what are you doing? So at the end of it, we have our system out logger, right? But what I've done to it is I've added the invocation handler log method calls. This is all familiar, what we already did. But I've wrapped that with adding an invocation handler on top of that, which will add the date to it. So this invocation handler, when I get it, and the method name is log, right? Because this is just a reflection, right? I'm just saying, hey, this is the name of the method, here's my arguments, go call it in Java somewhere. So I'm able to take that method, invoke it, but instead of passing that one log message that I got, I've now taken the first argument, which I know is the message, and then I've added the date to it. And so if it's any other method, it'll just do the normal thing. So let's go back and see how that works. Run. And so what we got is a lot of stuff. But what we do see here is that we ended up doing the date prefix, because we were able to, in this one here, date invocation, we were able to add that ourselves. So if we took this out real quick, and we just said args, arg0, oh my goodness, live coding. And then we ran it, you won't see that date stamp anymore, right? So this is a cool party trick, right? Like, hey, I know reflection. It's pretty sweet. But the thing that's really useful about this is, like, if you just had your normal interface that you instantiated, you would just go ahead and have, use a delegate pattern, use interceptors, Kotlin flows, anything else that you have that implements an interface. But what if you get a third-party SDK that you didn't instantiate, right? So you get, I don't know, this is not a good example, but let's say you got like the Crashlytics SDK, or well, that doesn't even exist anymore, right? So the Firebase, but you get some SDK that has a like singleton instance. It's already been created for you. It implements an interface, but you don't have any way to change the behavior of that. So whenever you call it, it's just going to call what they made. But as long as it implements an interface, you can add your invocation handler, like we had back here. You can just add an invocation handler onto it, and you now have the ability, when you use your proxy instance instead of the original one, you now can do anything you want before you call them or after you call them. And so it's a really powerful tool. That's probably not a good idea, but there are some instances where it works really well when you don't have the ability to control that instantiation and where those objects are happening or being created. So let's let this conference proceed, and we'll pass on my talk. So thank you very much.